Alright, friends, where did we leave off? We finished the assignment operators. Now it's time for relational operators. Okay, friends, let's move on from here. Runner. What do we mean by relational operators? I mean, what kind of relation is this? Now, between two variables. It examines the situation of two values we've given, or two variables, in relation to each other. So, how does that work? For example, think of it like this. Let's say a student has a grade. For instance, a student has a midterm grade. Let's say it's 40. The student also has a final grade, 60. You're going to calculate this student's average grade. What would you do? You'd add the midterm and the final. Then you'd divide by 2, right? You'd find the average. Now, did this student pass? Or did they fail? How will you determine whether they passed or not? This is where you check if the student passed or not. In other words, for a variable, the status of that variable according to a certain criterion, the thing you compare it to, we call that a relation. So, you're basically saying this. If the student's average is greater than 50, you say, this question has an answer, friends. Is this greater than that? If it's greater, then it's true. Let's write it like this. If it's greater, it's true. If it's less, it's false. That's the logic. That's all there is to it. Whether something is equal to something else, greater, less, or not equal. All of these, friends, are included in what we call a relation. Now, let's take a look at the example I just did, along with its outputs, and see how it works. Now then, let's say integer. Let's call it midterm. Midterm grade equals, let's say 50. Let's also say integer final grade for this one, equals. Let it be 54. So, I'm saying average now. Of course, integer average equals. Let it be midterm grade plus final grade divided by 2. Let's divide it directly by 2. So, what will the situation be now? We will analyze the average according to a certain value. Then, let's print the average on the screen first. Let's see what it comes out as. Then here I say, I'm going to ask if the average is greater than this. Let's check right here. Let's see, I say average greater than 50. Is the average greater than 50? It's a relation, you know. Greater than 50. Let's see, what happens if it's greater? What happens if it's less? Let's look at the result here. What was the average value? 52. What was the result? Look, let's write it like this. Let me write it here. I'm increasing the average grade. And I'm also increasing the relation value like this. I'm putting this operation in parentheses. Now, when I run this, let's see. Look, the average grade is 52. Relation value is true. What does true mean? True means this, friends. It means a new variable has appeared. I hadn't explained this variable when discussing variables. Some topics require the right time to understand. That's why I'm mentioning it now. Friends, there's a variable called Boolean. The Boolean variable. This variable is like a little box. A bit. So, what else could a little box, be? It could be 1 or 0. It could be 1 or 0. So what kind of variable is this? A variable with a value of true or false. Or a right or wrong variable. Or I. Off variable. So, you can use anything that is the opposite of each other. On, off, present, absent, true, false. Think of it like an electric circuit. You have a switch at home that turns the lights on. You press it, it turns on. You press down or up, and it turns on. When you do the exact opposite, it turns off. On, off. So, true or false. If an operation is correct, it gets the value true. If it's wrong, you get the value false. Here, is the average greater than 50? The average is 52. So, is 52 greater than 50? Yes, it's greater, right? Yes. What's the answer? True. So, you can also call it something else. Yes, no. You can say that too. So, what's the result of this relationship here? Yes or no. Alright, are there any other things? They're all the same, guys. So, all of these relationships we can use here actually give a true or false answer. Let's write out all of these relationships one by one. What was the single equals sign, guys? The single equals sign was the assignment operator. So, what about the double equals sign, then? Here, it's related to relationships. Guys, this is the double equals sign. It's used when two values are equal to each other. That's the situation they're in. So this, is it equal, is what it's asking. Look, we can do it like this. Let me copy this with Ctrl+C and write it here. Look at the question. So, I'm saying, is the average equal to 50? How do we ask this? Like this, guys, double equals. We're asking, is the average equal to 50? What's the answer? No, because the average is 50. I mean, is 52 equal to 50? It is not. Let's see. What does it come out to be? Let's check the answer. Is the average equal to 50? What's the average? 52. No, it is not. Look, lots of nonsense. That's the logic, guys. Here, it's the greater than sign you know from math. The less than sign. Greater than or equal to, or less than or equal to. Sign. It's the same. Nothing changed. So, you're saying this. Is the numerical value presented on the left side greater than the one displayed on the right side? In the same way, is the one on the left less than the one on the right? Is the one on the left greater than or equal to the one on the right? It might not be greater, but it could be equal. Isn't that right? For example, if I had written it like this. If I put 52 here, if I had written it here or not. Let me copy this with Ctrl+C. I'll paste it here. Is the average greater than 52? is than 52. The average is not greater. I'm saying 52. Is the average greater than 52? Guys, no, it isn't. But is it equal? Yes, it is equal. Look, now while the answer to this comes out as false, what about this one? Is it greater than or equal to 52? When you do it like this, what will the answer be? It will be true. Because is the average greater than 52? It is not. So, is the average greater than or equal to 52? It's not greater, but it is equal. That's why this one also came out as true. So, these are the basic concepts here, friends. And here, we have a question that's different from all the others, friends. We have a question about the exclamation mark. What is it? The exclamation mark actually means not. Not. It's used in that sense. You use it to negate something. What do I mean? When you say exclamation mark equals, it works like this, friends. Are two variables not equal to each other? They are not equal. Is that so? That's what you're asking. It's a bit of a sentence. The question turned out a bit different. Two things are not equal to each other. You're actually asking, aren't they equal? All right, let's try this, friends. Now, normally, here, is the average equal to 50? When you ask, is it equal? Friends, what do you say? No, you answer, the average is not equal to 50. It is not. So, what happens if I put an exclamation mark here? What happened to this question? Now, is the average not equal to 50? Sorry, wrong creation. Is it not equal? Look, what? This exclamation mark. I deleted the exclamation mark. Exclamation mark. We are asking, is the average equal to 50? Is the average not equal to 50? That's what we're asking. So, isn't the average not equal to 50? What's your answer? Yes, the average is not equal to 50. Yes, that's the answer you give. Look, now when you run it. Is this equal to that? Is the average equal to 50? No, it is not. So, isn't the average not equal to 50? What's the answer to that question? Yes, the average is not equal to 50. Here, in these kinds of relationships, the only thing you need to do is ask the question correctly. If you ask the question correctly, you'll get the right answer. People usually focus on this here. Was it like this? No. Did it become 1 or 0? Was it? You're focusing on the code. Guys, please don't focus on the code. I especially tell my students this when they're doing these codings. You don't focus on the code. You focus on understanding. You focus on logic. If you're writing code instead of talking about logic, instead of thinking logically, if you're focusing on the code, well, good luck. After a while, even you won't realize what you're doing. You won't be able to get out of the code you've written. You're asking questions in a logical way. These are things you already know. You just need to ask the right question and get the right answer. That's it. Relational operations are like this too, guys.